All right, now welcome back to our um, online class. And today I will be teaching you what is this number system all about. So, in my last video, we have discussed that a number system, let's say, when we say a number system, it is actually divided into four types. The first type is the decimal system. So I will write this as the decimal system, or it is commonly called as the base 10 system. So we can call this as the base 10 system. Okay. When we say base 10 system, meaning to say the numbers the possible numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the possible numbers in a number system. Like for example, if I have here a number which is 125, means 125 can be represented by 100 plus 20 plus 5. Okay. Now, if we are going to go back to the basics, now let's say I have here 125. Okay. This is my 125, and we are going to discuss more about the place value. So I have here 125, and we are going to discuss the place value of this number. So in this case, the place value of 5 is actually ones. That is the place value of 5. Ones can be represented by 10 raised to 0. The place value of 2 is 10. That is represented by 10 raised to 1. And the place value of 1 can be, this is 100 or 100, that is represented by 10 raised to 2. So if you will notice, okay, 125 can also be written as 1 multiplied by 10 raised to 2 plus 2 multiplied by 10 raised to 1, and then 5 multiplied by 10 raised to 0. This is very simple because we have known this before. So the result here is 125 base 10. That's how you write decimal numbers. Now, base 10, so for base 10 numbers, you may write the base or you may not. Okay? That's the rule for base 10 numbers. Now, we go to the next type of system. We call this one your binary system. Okay, let's name this as your binary system. When we say binary system, we also call this as your base 2 system. So base 2 system. So when you say base 2 system, the number can only be represented by 0 and 1. So binary system is used in our computer program. So the language that is read by your device is only 1 and 0 inside your computer. Okay, take note, if you are going to create a program and then you have to compile that program, the program will be converted from the higher level language going down to the machine language. Machine language is purely ones and zeros. Now that is actually the language that is understood by the machine. Okay, now going back to the number system, I have here an example of a number system that is base 2 system. Let's say I have an equation here. We have 101, okay, 101 base 2. Okay, now as I have said a while ago, now let's have an example here. Supposing I have here a base 2 number, which is 101. So you can say this as you can read this as 1101 base 2, or you can say the binary 101. Okay, now for binary numbers 101, so we are going to represent this now in terms of its place value. So we will represent this in terms of the place value. So I'm going to write here 101. Let's use the blue color here. Let's say 101 binary, and we will know what is the place value here. Take note, since this is your base 2 number, 1 here will have a place value of 2 raised to 0. 0 here will have the place value of 2 raised to 1. And 1 here will have the place value of 2 raised to 2. So that will become 1 multiplied by 2 raised to 2. That will be 4. Okay. The plus is 0 multiplied by 2 raised to 1. That's 2. Plus 1 multiplied by 2 raised to 0, which is 1. So if we are going to add all of these, the result would be equivalent to, take note, this is 0, this is 4, and this is 1. The result is equivalent to 5. So 5 here, base 10, is the value for your binary number 101. So to make it simpler, we can multiply this by 1, multiply this by 2, multiply this by 4. If you have another number here, you multiply it by 8, multiply by 16, multiply by 32. That's how it works. Like for example, so for 101, it's 1, 2, 4. Let's say 1 times 1 is 1, 2 times 0 is 0, 1 times 4 is 4. 4 plus 1 is equivalent to the decimal value of 5. So that's the value. That's the value of our 101 in terms of the decimal value. 101 binary is actually equivalent to 5 in decimal. Okay, now let's have an example here. Again, I have here let's say 1011, no, base 2. Okay, I have here 1011 base 2. Now we are going to find what is the value in base 10. So 1011 base 2, what is this in base 10? So base 10. What is this in base 10? Base 10 means decimal number. So what we are going to do here is to write the number first, and this time, instead of using, okay, take note, this is base 2. Instead of using what do you call this? The place value, I will be multiplying this by 1, 2, 4, just like what we did now in our previous example, 8. I will do that. So now if we are going to multiply this by 1, okay, let's start with this one. 8 multiplied by 1 is 8. 0 multiplied by 4 is 0, of course. 2 multiplied by 1 is 2. 1 multiplied by 1 is 1. So this is 10 plus 1, which gives you 11 in decimal form. So meaning to say, the binary number 1011 is equivalent to 11 in decimal form. Okay. Now, let's have a comparison here. Let's start. I have here a 4-digit binary number. So I will represent this as a, let's say, this is my decimal number. Okay. And opposite here. Okay, I'm sorry for that. Okay. What's this? Okay. Okay, opposite. My decimal number is my binary number. Okay. Let's start with a decimal number of 0. Okay, now I will be comparing the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's say 9. Okay, 9. Okay, okay. Now, 0 in binary number, let's have a 4-digit binary number. 0 in binary number can be represented by, okay, I will represent 0 as 000 base 2. Okay. 000 base 2. We will understand that this is a binary number. Okay, okay, that is 000 base 2. And that is the representation of the number 0 in decimal form. All right. Now, how about if we are going to represent 1? So 1 is written in binary as 0001 base 2. What about 2? 2 is written as 0010 base 2. What about the next one? Okay. The next number is 3. So that is represented by 011. Take a look at the numbers here in the binary form. So if it changes for 0, 1, okay, 0, 1, okay. And then for the number 4, okay, how do we represent number 4? Number 4 is 0, 1, 0, 0. So, number 5, how about number 5? Can you guess it? Of course. We have 1, that's 4. We add here 1, that's 5. What about number 6? Number 6, okay, you have here 4. If you change that, it becomes 4. And if you change that, it becomes 2. So 2 and 4 becomes 6. What about 7? 7 is represented by 1, 1, 1. 8 is represented by 1, 0, 0, 0. 9 is represented by 1, 0, 0, 1 base 2. Okay. That's how the comparison between the binary number and the decimal number. So this is very simple. Like for example, let's draw something here. Okay, example. Okay, I have mentioned this a while ago that the value, the place value here is 1, 2, 4, 8. Like for example, if this is all 0 multiplied by the place value here, the result will be 0. Now, if I have here 1, no, multiplied by the place value of 1, no, okay, take note, the place value here is 1, 2, 4, and 8. Same is true with this one. So this is all 0, and this is 1. And again, this is 1, 2, 4, 8. Okay. That is the place value. So it actually, the result will actually be 2. Now, let's try one here. Let's say 7. Okay. 1, 2, 4, 8. So 8 times 0 is 0. 4 times 1 plus 2 times 1 plus 1 is equivalent to 7. Let's say I have here 8, 4, 2, 1. So all of these become 0. 1 times 8 is 8. So that's how you represent the binary decimal form, or that's how you represent your binary numbers in decimal form, or vice versa. That's how you represent decimal numbers to binary numbers. You can also do that. Okay, that's how you convert decimal number, a binary number to decimal form. Okay, now let's talk about conversions later on. Okay, let's have octal numbers. When you say octal numbers, octal number system. When you say octal number system, it is referred to as base 8 system. So when we say base 8 system, it means the possible values are 0, 1, 2, 3, 4, 5, 6, 7. These are the possible numbers in the octal system. Like for example, if I have here an octal system, let's say 3, 1, 2, okay, let's say 31, 32 octal system. So this is base 8. What is this in decimal form? Okay, let's create a problem. What is this octal system in decimal form? What is octal system? What is this octal system in the decimal form? Now let's go back to the basics of this. Now first, now we are going to write the octal system here and its place value. The place value here is 8 raised to 0. The place value here is 8 raised to 1. So this will become 3 times 8 raised to 1 plus 2 times 8 raised to 0. So this will become 3 times 8, that's 24, plus 2 times 1, that is 2. Take note, this is 0, raised to 0. I will erase this first. So to make this one clear, this is 8 raised to 0. Okay. This will become 2 times 1. So meaning to say, the number 32 in octal system is equivalent to 26 in decimal system. Now, we have tried that before in our Python program. Now, let's try to compare. Let's compare the number system. Okay, let's copy this one. I will copy this one. Copy. Okay. I will paste it here. Paste. Okay, this is the binary system. So I will include here, okay, the octal system. Okay, I will add, okay, insert. Okay, I cannot add anymore. Okay. Oh, anyway, let's just click here. So I have here my decimal number, of course, binary number, and octal number system. Okay. Octal number system. Okay. I don't like this anymore. All right. Okay, let's. Okay, now I think this is good enough. So for octal number system, when we say 0 in decimal number and in binary number, that is 0, 0. In octal number system, it is actually it is also 0. So for okay, now I think we need to change this to octal system, octal numbers, instead of using this one, because I cannot create any more the new okay, instead of creating a new column, let's just erase the binary number column and then change that to octal number column. So in decimal number, 0, that is also equivalent in octal number as 0, 0. So we can write this as 0, 0, base 8. Okay. That is in octal number. That is the representation of decimal 0 to octal system. What about 1? 1 is also 1. Take note, I am using a 2-digit number here. So let's just use 1 digit. Okay, I will be using 1 digit. Okay, I will copy this first. What about 2? 2 is also represented by 2. Okay. 2. 3 is also represented by 3. 4 is also represented by 4. Until when? Until what number? Okay, 5 is also represented by 5. 6 is also represented by 6. 7 is also represented by 7. But take note, 8, take note, in octal number, there is no 8. Thus, no, it will be represented as 1 and 0. Okay, the first digit will go back to 0, and it will carry 1 to the next digit. That is why it becomes 1, 0. In octal, that is equivalent to 8. All right. Now, in decimal, which is 9, in octal, this is 1, 1 in octal. So that is the representation of decimal number system to octal number. Later on, we will do more of this now as our example. Okay, now let's try another octal number here. Let's have an example. Okay, what is 45 in octal system equivalent to decimal system? Okay. Oh no, oh no. Oh, in decimal. Oh. I will erase that. So what is that in decimal form? Let's see. Let's see. Oh, okay, Control Z. Okay. I will erase this part first. All right. So what is the equivalent of 45 in octal to decimal? So what are we going to do here is to use the base value method. So first, now I'm going to write here number 45. Okay. And then take note of the place value. So I will be writing the place value of 5 here and the place value of 4 here. So the place value of 5, since this is an octal number, is 8 raised to 0. And the place value of 4 is 8 raised to 1. So what are we going to do now is to multiply the number 4 to its place value plus 5 to its place value. So that what is the result? So take note, 4 times 8 is 32. 5 times 1 is 5. So meaning to say, the octal number, okay, 45 is equivalent to 37 in decimal form. So this is octal in decimal form. Okay, any questions? Now we will have more examples in that later on. Okay, now we proceed to the last number system. We have letter D, hexadecimal system. Hexadecimal system, or commonly known as the base 16. The base 16 system. Now, okay, we have discussed this already, that the numbers presented in this hexadecimal system, or the elements of the hexadecimal system, is the numbers from 0 to 9 and the letters A, B, okay, C, D, E, F. That's the comparison. Okay, now let's copy this first. Okay, let's copy this one. Copy. And then, okay, let's paste it here. What is this 8? Let's delete the 8 first. Okay, I cannot delete the 8. I don't know why is it there. Okay, oh, never mind 8. So let's just, where is this 8 coming from? All right, never mind. Okay, I will paste it here. Never mind 8. All right, now instead of creating a new column, let's just change this to hexadecimal system. Hexadecimal number. Okay. Hexadecimal number. Okay, for a hexadecimal number, it is base 16. So I will erase this part first. I will erase this part. Okay. Delete. Delete. All right. Now I'm going to add more rows. Let's say 10, 11, 12, 13. Okay, 14 and 15. All right. Now, when we say hexadecimal number, it refers to the numbers used in computer programs. Now, take note, if we have binary numbers in your computer programs, it will take a lot of space. But if you are going to convert that to hexadecimal number, it will display, it can be understood by the reader or the programmer easily, because it will only take a few digits compared to binary numbers. Now, in here, we are going to compare decimal numbers to hexadecimal numbers. for hexadecimal number system, this is base 16. I'm sorry, base 16. So when you say base 16, 0 can be represented by 0 base 16. And 1 can be represented by 1, but this is in base 16. Take note, base 10, no, we don't need to write the base for a decimal number. This is 2, can be represented by 2. Of course, 3 is also represented by 3. 4 is also represented by 4. 5 is also represented by 5. Okay. Take note, no, I am just discussing the basic of number system. In your next subject, no, you will be refreshed, no, with this number system again. No. But that time, no, it will be more complex. Okay, we have 9. Okay, 10. Take note, in a hexadecimal system, there's no number 10. All right, but no, this is number 10 in decimal system can be represented by A. 11 can be represented by B. This is B. 12 can be represented by C. 13, well, that's fine. 13 can be represented by D. 14. 14 can be represented by E. And 15 can be represented by F. So these are the comparison of the two number system. From decimal to hexadecimal, this is comparisons. From 0 to 9, they are the same. But as you go along with 10, it becomes A, 11, B, 12, C, 13, B, 14, E, 15, F. Let's try. Assuming I have here, let's have an example here. Okay, I have here a binary number, let's say 12A. This is your hexadecimal number, right? So I have a hexadecimal number of 12A. Now, what is this in decimal form? What are we going to do now is to, okay, let's write it here, is to write the number 1 to A base, okay, base 16. Okay. Next, now we are going to change this to, we are going to write down its place value. So the place value of A here is 16 raised to 0. The place value of 2 here is 16 raised to 1. The place value of 1 here is 16 raised to 2. Now, if you are going to simplify it further, take note. A here represents the number 10. So, if you are going to convert that to decimal form, 1 here will be multiplied by 16 squared. Okay? Now, plus 2 here will be multiplied by 16. Plus, take note, A is 10. Okay? So, I will write 10, which is multiplied by 16 raised to 0. That's the place value. Okay, now I will be using my computer here to solve for the value. So 1 multiplied by 16 squared, now plus, we have here 2 multiplied by 16 raised to 1, okay, plus 10. 10 is actually A, okay, multiplied by 16 raised to 0. Press equal sign. 1 times 16. Okay, let's do the math here. what is the value here if we are going to multiply this one? What is 16 squared? Okay. What is 2 times 16? What is 10 times 1? Let's try. 16 squared is 16 times 16, right? So 16 times 16. Okay, let's try. 16 times 16. Let's do this manually. So this is 36. This is 9. This is 16 and 1. So this is actually 256. So this is 256 plus 2 times 16 is 32 plus 10 times 1 is 10. So you have 256 plus 32, that is 288, plus 10, that is 298. So this is 298 base 10. So meaning the value here is 298. That is in decimal form. Okay. Okay, that is in decimal form. That's 298. That is the basic of the number system. Now, I will not be discussing how to convert number system from one form to another form. That will be discussed in your next topic. Although I can also discuss it here. Okay, let's have a refresher then. Let's say I have here. Let's convert binary to octal. Binary to octal. So number one, I have here binary numbers. Let's say 1, 1, 1, 1, 0, 1, 1, base 2. So that is a binary number. Now, if you are going to convert this to octal, no, you are going to rewrite this in such a way that you are going to group it by 3. Let's group it by 3. Okay, 1, 1, 1, 0, 1, 1. Okay, this is base 2. So take note. Now I have grouped this by 3. By group by 3, the binary. I have grouped this by 3, and what we are going to do here is we are going to find the value of this in decimal form. What is this value in decimal? What is this value in decimal? Okay. Take note, we are going to convert this to octal. What is this in octal or base 8? So take note, what is this? 0, 1, 1 is equivalent to, oh yes, that's 3. What about 1, 1, 1, 1? Go back to your table. 1, 1, 1, 1 is base 7. And what about this one? 1, 170. Meaning to say, the value of this binary number is equivalent to 173 in octal form. Okay, that is very simple. Let's try to reverse the process. Let's say I have here 54 in octal number, and we are going to solve, we are going to find its value in binary number. In binary, what's the value in binary? So it is very simple. So all you have to do is to write 4 and 5, and take note, we are going to represent this in 3 digits. This is in octal. So if you are going to convert this to binary, just convert each of the digits. Like for example, what is the binary form of 4? 4 in binary is 1, 0, 0 or 0, 0, 1. That's in binary. What about 5? That is 1, 0, 1. That's 5. So therefore, 54 in octal can be represented by, I will erase this part, okay, is represented by 101, 100, but in binary form. So that's how you convert binary to octal. Take note, you have to group your binary into 3 digits and then convert that to decimal and then write the digits. That will be your octal. So that is binary to octal. Let's write another one. let's have binary to hexadecimal. Okay, when you say binary to hexadecimal, no, let's try to have an example here, assuming I have here binary numbers, binary 1, 0, 0, 1, 0, 0, 1, 1, 1, 1, 1, 1 in binary. Now we are going to convert this to hexadecimal form. Hexadecimal form, or shall we say base 16. Okay? Convert this to base 16. So what we're going to do here, what we are going to do here is we are going to group this into 4 parts. Okay, not 4. We are going to group this. I'll copy this for a while. Control C, Control V, and I will group this into 4. Group it by 4. So I have grouped now the binary numbers by 4, and then I will take what is the equivalent of this 1111 in decimal form. Take note, 1111 in decimal form is 15. Let's try. Why 15? This is 1, 2, 4, 8. That's 15. And 15 is equals to F in hexadecimal form. Are you following? Oh, yeah. Okay, what about this one? 1, 2, 4, 8. So the equivalent of this is, of course, 3. 1 and 2, 3. What about this one? 1, 2, 4, 8. So the equivalent is 9. So meaning to say, this binary number is equivalent to 93F in base 16 form. All right, now let's try to do the reverse. Okay. Let's say I have here a base 16 numbers. Let's say 1, 4, 5, base 16. Okay, let's say A, B, okay. A, B, C. Let's say A, B, C in base 16. So what is this in binary number? Okay, what is ABC base 16 in binary number? So what are we going to do here is to separate this one, A, B, and C base 16. Take note, the value of C, the value of A is 10, the value of B is 11, the value of C is 12. Now, we are going to represent that value to binary numbers. Okay, let's start with 10. 10, the binary number, the decimal number 10 in binary number is equivalent to 1010. Okay, 1010, that is 1, 2, 4, 8 and 2, that's 10, right? What about B? So B here, no, in, okay, B here in decimal, okay, take note, B is equivalent to 11. So 11 in binary is 1, 0, 1, that's 10, plus 1, that becomes 11. What about 12? 12 is equivalent to 1, 1, 0, 0. Now, if you want to check this one, this is 1, 2, 4, 8. So 8 to 4 is 11. 1, 2, 4, 8. 8 and 4 is 12. So the binary number equivalent of ABC in hex is equivalent to 1, 0, 1, 0. You copy. And then 1, 0, 1, 1. And then 1, 1, 0, 0 in binary form. Well, that's it for today. Now, I hope you have understand the lesson for the number system. Okay. Now, if you need more conversions, I can create another video for that. Okay, let's say we want to convert this binary number to this binary number to that binary number. I will give more examples on this next meeting. All right, until here only. Okay, see you on my next video.